Okay, so we're now going to look at a very different technique. F is some function involving cos and sine, where normally you have something on the top divided by something on the bottom. If you need that, otherwise you don't have any poles. Anyway, the technique is to use a completely different contour from what we've been doing before. It's basically just to change variable to z equals e to the I theta. Now, theta is obviously varying between a value phi and that value phi plus 2 pi. So it's going around one complete circuit. So effectively what you're doing, if you make this change of variable, is evaluating this integral around the unit circle. Okay? So effectively you're turning this, just by making that change of variable, you're turning this integral into a contour integral into it, and therefore you just get the answer by summing up the 2 pi I times the residues inside the unit circle of the function you get. So let's just see what happens if you actually make that change of variable. So dz is then equal to I times e to the I theta. We're going to change the d theta into, we want everything in terms of z, so therefore this is equal to iz. So, sorry, forgot the d theta. So this is iz d theta. So d theta is equal to dz divided by iz. And of course, cos theta, we know we can write as a half e to the I theta plus e to the minus I theta. So that's equal to a half z plus 1 over z. And sine theta is equal to a half 1 over 2i e to the I theta minus. So that's 1 over 2i z minus 1 over z. So if we make that change of variable, the integral we want to find then is simply well, you substitute this into the cos expression, so it's half z plus 1 over z and 1 over 2i z minus 1 over z, and d theta changes into dz divided by iz. And there we have it. So then we can evaluate this using the sum of residues. So this is just the unit circle, 2 pi r times the sum of the residues.